Hello, everyone. I'm delighted to see you all here today, and thank you for joining me. I'm Dr. Gafari Lukuman, and today we have an exciting session planned. Because of the time, we quickly go over the outline of our session to make sure we cover everything important. And we are going to start with a brief introduction of my background and the work I do. Then we will dive into the objective of this module as well as how today's topic align with those. So we are going to make this session interactive. I assure you, you will help choose the focus of our case study. And after that, we get hands-on with some group activities where you will apply mathematical models to solve some real-world problems. Okay, let's get started. My name is Dr. Gafari Lukumo again. I'm a scholar engaged with the field of mathematics and cognitive science. It might interest you to know that I completed my first PhD in mathematics at the University of KwaZulu-Natal in South Africa, where I specialized in numerical analysis. And my topic was numerical solution of the Klein-Gordon equation in an unbounded domains. Then after that, I earned a second PhD in cognitive science, so which is a collaborative program between Mohammed VI Polytechnic University in Morocco and École Supérieure in Paris. My research there focused on my side bias and its influence on how information is shared within group. Beyond my academic pursuit, I'm passionate about educational outreach, and I founded Math with Lugaf, which is an initiative that breaks down mathematics, complex mathematical concepts using the Yoruba language, making mathematics more accessible to its native speakers. Additionally, I established the Hotspot International Scholarship Forum. Some of you from Africa will have come across this, so which connects aspiring scholars with worldwide aspiring scholars worldwide with global scholarship opportunity. In this session today, we align our discussion with the core objective of this module, which is the professional mathematical scientist. So this module is designed not to only enhance your technical skills, but to deepen your understanding of how technical skills can be applied to solve practical and impactful problems. I'm aware you've come across Python, you know how to code in Python. I think you are going to find the course interesting today since you know how to do that. So today's objectives are very straightforward. Number one, you are going to understand the application of mathematical modeling. So together with myself, so we are going to explore how mathematical modeling cycles are used in real research settings. In the second part of the class, we are going to have a kind of interactive learning and decision making. You will actively participate in choosing which case study we will tackle in today's class. And after that, you are going to vote. So we dive into a case study based on the choosing topic, based on your vote. And you are going to get, a chance to apply what you learn by modeling scenario using Python in groups. Are you ready? Okay, like I've said, I want today's class to be interactive. Just think of me as your guide rather than just your teacher. I'm just your guide. We are going to explore how mathematical models can be applied to one of two potential real-world challenges. And I will need your help to choose which one. I will need your active participation as we decide together which projects to dive into. So I'm going to use Kahoot. I don't know if you are familiar with that. So for a live vote between two of my current research interests, one on how to improve fact-checking mechanisms, and the second one about applying spectral method to solve some evolutionary equations like Klein-Gordon equation, which I've mentioned the other time. So okay, now I want you to go to kahoot.it and you can enter the code I showed the other time. And it looks like from our votes, so it looks like improving fact checking mechanisms is the winner. I think that is fantastic. I was expecting you are going to select, spectral method. So, but it's just a testament to the versatility of mathematics and its application across various fields. And I know you are also curious because it involves media and public information. Okay, let's start. So let's have a closer look at my project, which is focused on improving fact-checking mechanisms to combat misinformation. And in the subsequent classes, so then we can also, focus on the spectral method if you like. So in this world with information from various sources like television, newspaper, and maybe your social media like Facebook, Twitter, so you know that the accuracy of news is more critical than ever. You know, my team and I, we are dedicated to improving the way we verify news to ensure the public receives reliable information. And you will agree with me that every day, we rely on information to make decision whether to come to class today. You don't know whether Dr. Lukman is going to show up. So whether to stay informed and connect with the world. However, not all information is, created. Not all of them are equal. So we have some of them that are misleading news. So they spread quickly. You might wake up to one story and find a contradictory report by evening. So this spread of fake news, the false or misleading information presented as accurate, poses a significant challenge. I hope you are following. So without diligent fact checking, then one can easily accept misleading information as truth. So the stakes are high as misinformation can influence opinions, fuel polarization, and cause widespread confusion. So you agree with me, some of this happened so during the United States election that was held 1 week ago. So our project embraces a unique approach which I call adversarial collaboration. So we bring together fact checkers from diverse backgrounds and viewpoints to challenge each other and collectively improve the accuracies of news verification. So this method helps to balance biases and enhances the credibility of the fact-checking processes. So in our study, we conducted two pre-registered experiments. So with roughly 900 participants from Prolific. I know if you know Prolific is a crowdsourcing platform. So participants were tasked with to review 16 news headlines. 8 of them are left-leaning and 8 of them are right-leaning. They are leaning to Republican. So and each pair containing one true news and one false headline on controversial issues in the United States. These are the example of what our participants see. And to assess the effectiveness of this fact-checking approach, we measured several key indicators. Number one, the trustworthiness of the news, the decision to publish it, its believability, and overall preference for the source of the fact check. And our findings were revealing. People showed a marked preference for and a greater trust in news that was fact-checked by a heterogeneous group of fact-checkers. What I mean by heterogeneous group of fact-checkers are those fact-checkers that comprise of people from that voted for Donald Trump as well as Joe Biden in the 2020 election. So this suggests that diversity among fact-checkers not only builds trust but also makes the news more likely to be published due to its perceived reliability and balanced viewpoint. So in essence, this project has significant implications for improving how we handle political charged information and fight misinformation. So, if we use adversarial collaboration, so we can enhance the public trust in media and ensure a well-informed society. So, and that's why I'm very excited about the potential of expanding this model and continuing to refine our approaches to fact check. Okay, now it is now your turn. So, I know you enjoy what I've just explained. When it comes to the question and answer, you can ask your question, of course. So now I want each of the group to use Python to model the scenario I've just discussed. You consider how different data types and sources can influence the effectiveness of fact-checking algorithm. I know you can do it because you are already familiar with Python. So then I encourage you to form probably an heterogeneous groups to get a mix of perspective and ideas. And probably you can model, the two groups, the heterogeneous, which is can be considered as mixed group, and homogeneous group as well. Probably, a group, a fact-checking group consisting of those who voted for Democratic Party and another Google voted for the Republican Party. So remember, my office is always open. If you need any guidance or you want to discuss your models, so you are free to visit me during my office hours listed here on the screen. You can come between 10 and 12 p.m. on Friday. So in 2 weeks, let me know if you need more time, but in 2 weeks, that's the deadline. So I want you to submit your Python code. So you can submit on the Google Colab, so which I'm going to share with you later. So thank you for your enthusiasm, and participation by participating today. I'm looking forward to seeing your innovative approaches and solutions. So have a great day and see you in the next session. Do you have any question? Okay, Matthew, yeah, you can use, a news item that's related to, that are related to UK, politics. You might not use that of America, you can use that of UK. I hope you understand. Yeah, and yes, Ada, the deadline is 2 weeks. So, but if you need more time, you can feel free to, reach out to me on email. You all have my email. So yeah, then feel free to reach out to me. I'm going to, I mean, uh, answer you. In terms of the Google Colab, I want you to use Google Colab so that we have all the, codes in a place. Then, if I have a feedback and you want to collaborate with people within your group, so you can do that easily, so without any problem. So, any other question? Okay, yeah. In the absence of any other question, thank you again for participating today. And I'm looking forward to seeing your innovative approaches and solutions. So have a great day and see you next session. Thank you very much. Bye bye.